This is a triangle, this is a circle, and this is a square. A 3-year-old can tell them apart. But if I asked you to write a program that can do the same thing from scratch, you would probably quit tech, join monastery, and raise goats for a living. Yet somehow your brain does this instantly on blurry images, rotated shapes, or even doodles made in MS Paint at 3 a.m. So how does a computer learn to do it? Welcome to the magical black box we call a neural network. A neural network is like a chef who has never cooked before, but after burning 50,000 meals, it somehow nails the perfect pizza. Inspired by your brain, it is made of tiny things called neurons. But unlike your brain, these neurons aren't full of trauma and questionable decisions. They just hold numbers. Each neuron gets a number between 0 and 1, depending on how much it thinks something looks like a pattern. Let's say we are building a network to tell apart triangles, circles, and squares. So you feed in an image. Every image is made of certain pixels. For example, this one is made of 28 by 28 pixels, which means we have total 874 pixels. Every pixel has a certain brightness, which is represented as number between 0 and 1. For example, completely black is 0 and completely white is 1. So all of these 784 numbers make up the first layer of the neural network. That's your input layer. It's just the raw data of pixel brightness, no magic yet. Then you've got a few hidden layers where all the actual magic, math happens. And then you have output layer that gives you the result. Each neuron in one layer connects to the neuron in next layer, and every connection has a weight. A weight in a neural network is like a control knob that decides how important an input is. Big weight means input matters a lot. Small weight means input matters a little. Let's try to understand the magic by an example of a neuron. You take all the inputs, multiply them by their weights, then add an extra adjustable number, which is called bias, to the neuron's calculation before passing it. Squish them through a mathematical function and then send them to the next layer. You repeat this over few layers and finally you get to the output layer. If you are lucky, it says something like this. The picture is not a triangle, not a square, boom, it's a circle. But how does it work? We show it a bunch of pictures of triangles, circles, and squares, millions of them, and tell it what the correct answer is. Each image goes through neural network. At first, the network guesses are garbage, but every time it messes up, it gets the feedback. It adjusts those weights just a little bit. That's how the neural network learns, and this process is called training. Eventually, after thousands of attempts, it figures out the exact sequence to solve it every time. That's what the neural network is doing. Guess, adjust, repeat a million times until it gets good. Training neural network is expensive and they need massive amounts of data. But once trained, they are insanely fast. They can power facial recognition, self-driving cars, and playing chess with you. So let's summarize. Neural networks are just stacks of numbers passing through a math tunnels. They guess, get yelled at, and adjust until they stop being dumb. Once trained, they are insanely fast. That's neural network in 4 minutes. Thanks for watching. I'll see you in the next one.